Another AI talk? Oh my God, you're still here? So many AI talks. Yeah, AI will generate code, do some prompt engineering, and thank you, I'm done. All right, get out. All right, here we go, let's do this. How many AI talks have you seen so far? Two? What were they about? Like code generation with AI? It was like do some prompt engineering, blah, 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 and done? That's the whole talk, right? Yeah, same talk. All right, same talk. Let's do this. You ready? Let's go. You ready to go? You're late. You're like 30 seconds late. No, you're on time. No, you're on time. You're good. You're good. Should we? Are we good now? Are we good? High five. Bing, you're up front. You're taking this seriously. Let's talk about, like, real quick, why do we need AI secure code generation? Do I have to convince anyone that AI for code generation is changing software development and we need to get into it and it's part of the future? Anyone here a doubter in AI for code generation? Anyone? Oh, you're a doubter. Oh, if you do this, you're a doubter. Why do you, can I give you a hard time real quick? What are your doubts? What do you not like about AI for code generation?
I mean, it's useful to bounce things off, but it doesn't give me good code, in my experience.
Okay. Can I ask how you're using it? Are you like opening up a prompt and generating code?
Sometimes I do that, sometimes I use
Copilot's is just a raw engine. Copilot's just same thing as opening up ChatGPT 4 and asking for code. Is that how you use it, respectfully? And again, I'm not giving you a hard time. I'm being seriously. I just want to know how you use it.
Yeah, I mean,
So my take on this talk is when you're using a raw AI prompt to do code generation, it's horrible. I don't care about anyone else in this room right now. They all get it already. I care about, what's your name?
Thomas.
Sorry? Thomas, this talk is only for you. Everyone else here doesn't matter to me except for you. Thomas, I want to show you how to turn AI for code generation into something that's into something that will change your life, that will revolutionize how you build software, that will convert you from one developer into a giant team, and will enable every single aspect of software development to turn you from a developer to a superhuman coding machine. And you'll never go back once you start using these engines a little bit differently. Are you ready to roll, Thomas? Are you ready? I only have one person in this room with me, Thomas. So thank you for being here. Now, AI is obviously a critical tool for software development, but the advantages are going to be radical. Speed, efficiency, creativity. I mean, everything that we care about from a quality metric is available in AI. But as its role expands, so does the need for emphasis on security and quality. The code that's generated by AI, as you've seen, Thomas, is sometimes functional, but it lacks all the security awareness, creativity, and all the depth that we get from a good human developer. And this is why this talk, for you and me, is so important, even though no one showed up today, Thomas. So we're going to begin by setting the stage by understanding how AI contributes to code creation, why security must be a fundamental consideration, and why AI lacks all the qualities that you're looking for when you use it raw, a raw prompt. And we're going to look at a couple techniques, and I'm going to give you some examples of professional quality prompt engineering, training with the React framework. If you came to my talk earlier, I talked about React security. Now we're going to take all the guidance from hey, you're back. Remember the React talk? That was okay, right? So we're going to take all of that guidance and convert it into a list of machine-readable instructions so we can generate secure React code through automation. That's where we're going to end up today. I'm not just going to blah, blah, blah. I want to show you, give you a list that you can take with you today, use it in Claude. I'm not a big Copilot fan. Sorry, Microsoft. Get your act together. 4.0, I like Claude. I even like Gemini, I think are better engines when you give it instructions. And the takeaway, Thomas, he just showed up. He's only the three of us now. So the takeaway here really is that AI is like a hyper-fast, brand new programmer who came out of like MIT or a good school. A great coder, but you got to train them. When you hire a new coder, do you just send them to go start releasing production code? I hope not. You train them in some way. Give them style guides, security guidance, what your best practice are, what you expect out of them. But imagine if you gave them those instructions and they went and did like 5,000 hours of work in a few minutes. And then you have to continue to train them. That's what AI is. It's like a hyper-fast junior developer that with the right training, they're going to do miraculous things for you. And this talk is about how to train them in some very, very specific ways. And the role of AI is growing fast. If you don't embrace this technology, you're out of a job. This is no longer some nice-to-have technology. This is a required augmentation that you're going to need to use as a developer, or you're out of a job. Because the people around you are using this. They're going to these talks. They're learning how to leverage it correctly. And the performance benefits on the low end are a 40% reduction in flaws and about a 60% increase in productivity. And that's if you're using it badly. If you're using it well, if anyone here, an architect level developer, been writing code for more than 20 years? So, we can turn you, with the right prompt engineering, if you understand componentry and architecture and code assembly, I don't want you coding anymore. You've been doing it for too long. But if you can get AI to do it for you with your architectural level knowledge, I can turn you by yourself into a large team of developers, able to build giant solutions, because you know what to ask for. A lot of us don't, but you do. So architects are going to be fundamental to modern software. It's going to be a revolution for your career if you leverage this technology. And those of you who do QA, you're super important. But the role of your average coder is going away. It's going to be architects and reviewers. Why do I need a coder when I can get AI to build really good stuff for me? I don't anymore. It's going to happen really fast. But architects, assembling componentry, I need you. And AI, like you're saying, Thomas, it generates a lot of iffy stuff. I need quality review more than ever, because we're about to enter an era we're going to spit out a shit ton of code, more than we ever have, because of him and AI and all the advancements coming out. This is an exciting revolution. I want you to be a part of it. But those of you who are like, I'm a coder, I'm cranking out code, I'm not quite an architect, I don't believe in AI, you're out. I don't need you anymore. You're out of a job. So get on board, leverage this technology. When we were writing assembly code, the assembly guys were like, C is horrible. I would never use C, because assembly is all I need. Guess what happened to those folks? They lost their jobs. So be a part of this revolution and learn how to use this technology to hypercharge your ability to write software for the next generation. Because right now across the world, we simply don't have enough developers, and that's going to change real fast as this technology advances. And believe me, it's advancing. Now, the problem is the current state of how AI is being used. Like, how do we build the models of today's AI? Most of the AI engines, and I think there's three I really care about: Gemini, the ChatGPT-4 technologies, including GitHub, and Claude. My favorite is Claude. Anyone know why Claude, even though Claude's not as great as a code cranker, why do you think I like Claude better than the GPT series? I usually use all three in a pipeline. You know why Claude's so great? It's like greased lightning. ChatGPT 4.0 is slow as freaking molasses because it's under so much heavy use. But Claude, which is a decent engine, I can make small, quick iterations with it better than any other engine. So I use GPT 4.0 technologies to build my initial boilerplate. I use Claude to do all of my rapid iteration, and I use Gemini for a couple other random uses where it's good. It does a lot of good crypto, frankly, in Gemini, because it understands Google Think well. And then I use I use the Amazon engine to do all my cloud engineering. And now I'm an architect. I've been writing code for 30 years. So by myself, using proper prompt engineering, I can build solutions in a matter of like 2 weeks that used to take me about 20,000 hours worth of work. That's where the industry is going. I want you to be a part of it. So the other thing is that AI-generated code is fed, all these models are fed with a mammoth amount of open source code. The rumor is that GPT 4.0 has about 4 trillion inputs. How much of that is good code? I'm gonna give you an answer. Not the majority. So because of how these models were trained on so much data, good and bad, what's coming out of it now is insecure code, because most code in the world is insecure. So we have that problem. Now, if you want to make a couple billion euros, here's what you do. Here's how you build an engine for the next generation. Number one, you get some funding. Number two, get about 20 of the world's best security-driven software engineers that you know and pay them anything that they want, the top possible rates. Then you meticulously go over open source projects that are of modern frameworks, and you handpick the updates that are high quality, and you only feed high quality secure software into a model at scale. And then the model and AI engine you get will only be trained on good code examples. No, there's a few companies trying to do that today. It's going to be hard to do this, but that's going to be the future, and it's coming up in about 3 years. I'm sorry I lost you. I wish you the best. They'll be out of a job soon. So there's a lack of built-in inherent security, and there's a big over-reliance on raw prompts right now. When you're just using GitHub Copilot, you're using a raw prompt that's fed with a lot of bad code. So we need to do prompt engineering. And when you don't do prompt engineering, this is what studies are showing us. Resource leaks, not closing streams, insecure handling of sensitive data, bad exception handling, bad concurrency, terrible use of complicated third-party APIs, misconfigured security context, and horrific dependency hell using old, out-of-date, or conflicting libraries. And if you use a raw prompt, Thomas, and you run into this, I would give up too, I understand. Because what comes out of it, even today in the best engines, are this. And it's a problem, and it causes a lot of us to shy away and give up on this technology. But this is just the beginning. This is not where we stop. And why we should care about this is because a lot of the problems in software development, the lack of developers, the security problems, the complexity of building modern microservice architectures, the growing complexity of software in general, this is a burden. And AI is going to help us solve a lot of these problems. It already is helping us solve a lot of these problems. And so what we need is the big buzzword of the whole conference. We need prompt engineering. And I'm not just going to talk about it. I'm going to give you a real-world example that's going to help you today. So I'm not just here to blah, blah, blah at you. And so we need prompt engineering because just like a junior developer, we have to train AI to give us good code. And again, we also need a structured lifecycle where security is built into the prompt from the very beginning. We want to ensure that AI-generated code adheres to security standards. We want to facilitate the continual refinement of prompts based on security validation and code reviews. And this is called, again, a lifecycle approach to AI code creation. At the first step, we're going to use prompt engineering with training instructions. But at the final phase, we're going to use multiple engines for our next talk. We're going to use multiple engines for different purposes, like maybe ChatGPT-4 is our product manager, maybe Gemini for our QA in crypto, maybe, again, Amazon's GPT for creating cloud configuration. The future is not any one engine. The future is a series of engines for different roles and use cases. I see a lot of researchers working on this already, and some of the prototypes I've seen blow my mind. I've been coding my whole life. I don't want AI to take over my job, but I also want to keep up with the coding trends. In every major shift in technology and software engineering, you either move forward with the trends boldly, or you're behind very quickly in your ability to innovate. So it's time to charge. So when it comes to a life cycle for prompt engineering, it starts like any project in software development. Define security requirements. And do this in an English way, or in a Danish way, whatever your language of choice is. Tusen tak. So whatever your language of choice is, identify security requirements. Then you want to translate those English security requirements, or those human security requirements, into a machine-readable prompt structure. Next, we're then going to feed those requirements into a prompt and generate and validate AI-generated code. And you're not going to get it right the first time. Then you want to do small iterations. When you see a mistake, you refine the prompt, refine the instructions permanently, and go back and ask a fast engine to iterate on one small problem at a time. I usually say, this code is awesome. Don't change anything except for this one function, fix this only. And I have a lot of good luck in the rapid iteration cycle of writing software. And again, those of you who are skilled at software engineering, we still need those skills. The big risk is, when we look ahead 10 years, that coding skills have faded, and we have architects and QA, but we've lost the art of programming. And if you're worried about that, I am too, absolutely. But this is where we're going. So step one, identify security requirements. You want to follow security principles, right? Input validation, secure data handling, authentication, authorization, encryption. And we want to list specific security standards, things like GDPR, HIPAA, PCI DSS, or leverage standards like OWASP, Application Security Verification Standard, and refine them for your project, right? And we want to focus on not every single vulnerability, but the common vulnerabilities: cross-site scripting, SQL injection, cross-site request forgery, data leakage, and then clearly outline the expected security outcomes for code generated, like input sanitization, encryption of sensitive data. Now, in this step of the life cycle, again, we're identifying security requirements like hopefully you do for any project. And again, beyond the basics, as you see your code making mistakes from AI and you see a security mistake, that's not a problem. That's an opportunity to go back and refine your prompt permanently. In fact, my list of instructions for React development, I have it under source control like any other valuable artifact. Although my React code is important, but the prompts I'm using for it are worth their weight in diamonds because it helps me repeat this kind of iterative, fast AI development over and over and over again. Next, we want to translate these requirements into a prompt structure. So we want to convert security requirements into actionable, clear instructions within the AI prompt. I don't think people are good at doing this. So what I usually do is I whip out all of my instructions in my language, which is very verbose and American, unfortunately. Then I use an AI to refine those. I'll literally ask my AI engine, please behave as an expert in converting human requirements into machine translatable requirements for AI code generation. And the AIs are like, I am good at that, as a matter of fact. That's my job. And they're happy to help me with this. I usually pass it through all three engines and cross-compare to see which ones I like the best. So I can read them and the AI engine can read them. And I want to be really clear on my language when I'm describing it. So my English description is super verbose. The translation is usually a lot more concise. And I want to set boundaries and constraints. I can say, hey, look, don't use the eval function. Please don't use inner HTML. I can also give it really clear boundaries. Boundaries are good in life, in any relationship. That goes for your AI as well. Create example prompts as well, where you have a list of instructions that you can reuse over and over and over again. Because I find out the first big AI project, I had a certain level of efficiency. But I changed my prompt as I went for each component, each language, each architecture set. And the next project, I got even more performance. And I keep refining each time. I'm like my sixth big AI project, and I'm rocking by myself. Dancing with myself, okay. All right, so the next thing I want to do is I want to generate the code and validate the AI-generated code. I'm a security engineer by trade as well as being a developer. So what kind of tools do you run code through in a security lifecycle? Static analysis? Dynamic analysis, third-party library scanning, secret scanning, cloud configuration scanner. I have an elaborate tool chain. We call that DevOps or DevSecOps. And I use all of the best practice security tools and scanners that I can use to review my code. Then I just ask another AI engine. I have Gemini create code, and I have GPT-4. Hey, can you review this code for security vulnerabilities? They almost do a better job than the big $1 million tools as well. So I use scanning tools and I use AI review in a cross-compared way. And I do this through automation, right? I'm not doing this by hand. So now I've done an elaborate security review. But the other thing is there are metrics that are really important that no one has used in years. And so I also have a set of quality control metrics I'll talk about in just a moment that really helps AI generate not just functional secure code, but the most important thing in my world, readable and maintainable code. I want humans to review some critical code. I want to maintain this over time. And if people stop being able to read the code, my reliance on AI will accelerate to the point that I'm not comfortable quite with yet. And then, again, I'm going to iterate and make small changes. I analyze generated code, I run it through elaborate automated security testing, and I see where things are a problem. I incorporate the feedback from my security scanning and quality scanning change, and anytime I'm making a change, I'm going back to my prompts and changing the instructions for future iteration or for the next project. Because again, I think the code you write is less important than the set of instructions that you build. That's the diamonds for the future. And I repeat this cycle until the standards are met. And this is why I think Claude is so important today. Anyone here using Claude for anything at all? A lot of people, Claude doesn't get a lot of attention, right? But it's still a world-class engine, a world-class LLM. And when I try to iterate fast on GPT-type technology, GPT-4 primarily, it's a slow engine. And that's my experience. No one's using Claude. You are? So Claude's got this giant cloud infrastructure that's not heavily used, where ChatGPT-4 is soaking Microsoft's cloud so bad, they're buying every GPU they can get their hands on. So today, the fastest engine by a wide margin is Claude, so I can use that as my iteration engine with the same prompts, and it lets me rock faster for the iteration cycle. So again, the other thing is, when I'm talking about functionality, there's some best practices that I found that are a little more subjective that really helps me create better code. Be specific. When instructing AI, give clear instructions, context and purpose. Explain the purpose of the code you want. Help to understand the bigger picture. Include constraints. Mention constraints or limitations like performance or compatibility. For me, my world, there's a trade-off between, do I have more CPU available or do I have more RAM available? And I can write code to handle either of those situations based on what cloud architecture or what my cost is to run my software. Specify security considerations. We'll talk about that in detail. Ask for explanations and comments of why AI is generating what code. They'll do it easily for you. And now when you're reviewing that code, especially security critical code, you can see the thought process well as to why that code was generated to help you iterate faster. And again, iterate slowly and request best practices. I'll ask for best practices like for my Java work, I'll ask for domain-driven security. Anybody ever heard of this? This is a relatively new area where when you build an object for like a user, username, first name, last name, address, country, it's usually strings you're moving around with or some types. I think this is a bad idea. My constructor and my user object does input validation. So you can't, in my world, you can't even instantiate a user object unless a username is ASCII between 3 to 20 characters. The address only has certain characters of a certain length. This is called, again, domain-driven security, where I have validators built into the class. So at construction time, I can't even build a user object unless it adheres to all of my security standards. And now I know when I have a user object that it adheres to all of my validation standards, and that's helpful in a variety of different contexts, right? And also, your prompts are, again, they're worth their weight in gold. I put them under version control and augment them as a team for each language. I have one for React client, one for React server-side rendering, one for Java 8 API struts, one for Spring, one for modern Java Spring. And I have different teams working on these. And again, every day that we increase the detail of these prompts, the more powerful we are in that project and future projects. Now let's get specific, right? When I say be specific, give clear and detailed instructions about the codes you need when you're asking for certain functionality. The prompts that we start with are general requirements. Then you have to ask for functionality. This is where this comes in. This includes starting your programming language you want to code with, describing the exact functionality, mentioning what libraries you want to use or frameworks, the exact versions. The more clear your instructions, the more you're going to help generated code meet your expectations, and it'll integrate more smoothly with existing systems. Like, can you create a Python script that reads a CSV file, outputs the average value of a specific column using pandas version X? In this example, we're asking for a Python script with a very specific function, reading a CSV file. You can also specify the exact version of Python and the exact version of the Panda library for even more depth. Be specific as you can. Verbosity in any kind of engineering discussion is usually a good idea. Next, context and purpose. when requesting code, it's important to provide the context or purpose behind what you're trying to do. This will help your AI understand the broader scenario in which the code is going to be used. It allows it to generate a solution that fits your needs from a much higher level. I need a Python function to parameterize user inputs to prevent SQL injection in a web application. And these are really basic examples, but you get the right idea. Next, we have include constraints. Hey, give me a Java method to sort an array of integers using quicksort, but I want an emphasis on using CPU and minimizing memory because of a certain cloud environment where they charge less for CPU but a lot more for RAM. So I can tweak my code to adjust to that so I have high-performant code based on this specific criteria, right? Next, we have specify security considerations. So, for example, you might want to specify that passwords should be hashed. Anybody know, if you're building an authentication system, what algorithm should we use for password storage? There's only like two. One's bcrypt. That's a very low memory utilization, one-way algorithm that's slow on purpose. The other one is the algorithm of the day. The big standard is Argon2ID. With Argon2ID, I can configure RAM utilization, CPU utilization, and I can limit the number of threads that are computing on Argon verification. This is best practice for an authenticator. So I want to specify this. Write me a node function to hash passwords using bcrypt. I want to use low memory with the work factor of 11 for secure storage in a database. This is why architectural knowledge is going to rule for many years. As a security engineer, you need to know these things, to ask for it, to get it, because a lot of developers in open source don't use the right function for an authenticator. And so there's a whole guide I recommend you look at, and I fed this into one of my GPTs to generate prompts called the OWASP Cheat Sheet Series. There's also the OWASP Application Security Verification Standard. If you don't have this knowledge already, you can take the cheat sheet series for security, a living encyclopedia, and the ASVS standard, extract it, prompt it, convert it into your language, convert it into machine-readable language. You now have an initial set of prompts that are general purpose for secure code generation. One of those cheat sheets, it's the password storage cheat sheet, and it will give you a guidance for bcrypt and for Argon2ID if you have low or high RAM utilization needs within your software. So again, AI is not going to solve all our problems. You got to ask for the right questions. We still need that security architectural level knowledge to get there. Also, ask for explanations. Remember, AI is not perfect, Thomas, and you're right. It's easy to dismiss. So when I'm using a faster engine, though, I ask the code to clearly explain, as if I was a skilled programmer, why are you doing each step? So that way, when I'm doing my review and I want to rapidly iterate, I understand the thinking behind what each line of code means. And then if I don't want to keep that, I can say, all right, revisit the code, scrub the comments, and make the comments more high level for a future reviewer. So I can switch the comments out when I'm done with my iteration process. Next, I've mentioned this a dozen times, iterate in small steps and refine. The initial response will never be perfect. This is why using AI for code completion is something I typically don't do, right? Because I want a more elaborate life cycle with my AI. Microsoft was selling Copilot, one of my companies, and they say, just use Copilot. You don't need prompt engineering. Just use it raw and you're good to go. And I dismissed him at that point. The talk today from Microsoft was, you need to do prompt engineering to use our technology properly. So I give them a lot. I got just hearing that today, I'm going to give them another chance and do a new cycle with this technology is changing fast. If the Copilot didn't really have easy prompt engineering interfaces, it does now. So I'm going to give them another chance because I need that to rock with this technology better. Request best practices. Once in a while, I let down my Java and I use this other language called C#. That's like, what would happen if Java was actually written by sensible people? That's I admit. I still do a lot of Java, but C#, I cried when I first started doing C# because all the horrible problems of Java were largely fixed. So there you go. There's a nod to the .NET community. Hello, everyone. When I'm using C#, I usually ask my engine, please use solid principles. Have you heard of this before? Solid stands for, number one, the single responsibility principle. A class should have one and only one reason to change. This means a class should be focused on a single functionality and avoid accumulating unrelated functionalities. Two, for solid, O is the open-close principle. Software entities like a class should be open for extension, like adding a new functionality, but closed for modification. Avoid changing existing code. This is achieved through techniques like inheritance or dependency injection. L in solid is Liskov's substitution principle. Objects of a superclass should be replaceable with objects of a subclass without altering the program's correctness. So if you have a function that works with a certain class, it should also work seamlessly with the subclasses of that class. Next, the interface segregation principle. Clients, other parts of the code, should not be forced to depend on interfaces that they don't use. This means creating smaller, more specific interfaces instead of large general-purpose ones. And last, the DIP principle, dependency inversion principle. High-level modules should not depend on low-level modules. Both should depend on interface abstractions, and abstractions should not depend on details, and details should depend on abstractions. Now, this principle promotes loose coupling between different parts of your code. When you follow the solid principles, your code is easier to understand, easier to maintain, and extends as your project grows in a much easier way. And AI understands this. So this is when I'm doing pure object-oriented programming, I'm doing mostly C# work, I specify, please use solid principles, and I spell out the acronym, and I get that in a really powerful way. Not always great, but powerful, no question about it. And so, again, put your prompts under version control, right? I'm going to show you one in just a few minutes. And so, these, track changes to maintain consistency for collaboration, history. You may have to roll back if some of the changes someone made starts to break in a new engine. The challenge here is my prompts are changing all the time, but so are the engines that I'm using. So it's a moving target, and it is challenging. I may add a bunch of new things to a certain engine, use it for another engine, and it breaks down. So I'm often rolling back a few steps, rolling forward, rolling back a lot more than I do in my typical code projects when it comes to prompt engineering, because the tech is moving fast, and I got to move fast with it. But it's worth it. The performance gains are worth it. So I'm still worried, Thomas. With all this in mind, I'm still seeing a lot of problems. Like AI will generate 300-line functions on me it's well written, but that's not something I would normally do. So it gives me code that's performance friendly, but it's soaking up too much CPU and using minimal RAM or whatever. So I need really specific evaluation metrics so I can understand like what I just built from a traditional static analysis point of view. These are metrics I'm going to show you that I don't hear people talking about anymore. From a reliability point of view, I'm looking for a low MTBF, a low mean time between failure. And I can usually look through a history of a code base to get this metric. This is the reliability of a system by measuring the average time between system failures. I can predict when failures are likely to occur again, allowing for more proactive measures. MTTR is the mean time to repair. It measures the time it takes to restore a system after failure. Service level objectives define the acceptable level of service performance and reliability for a system, uptime, response times, and similar. The error budget is a metric that defines the maximum allowable errors or downtime within a service level objective, and request latency measures how quickly and efficiently a system handles requests. This is the metric I use to evaluate how the system operates. I don't put this in prompt. I evaluate this over time when the application is running to see how good the software is from an overall reliability point of view. But when it comes to code quality, I can prompt this, right? Number one, I have code coverage. I want to understand the percentage of code that's covered by my test automation suite and get up above 90%, right? I don't prompt that, but the rest I do. The next two are super important. The next one is cognitive and cyclomatic complexity. Has anybody heard of these before? So only like 4 or 5 of you raised your hands. A lot of folks don't even talk about this anymore. But cyclomatic complexity is the ability to write maintainable code. It basically measures the ease with which human brain can, It measures the complexity of the code by counting the number of independent paths through that code. If you let AI rock, it'll, between 1 and 10, it's generating like a 7+ when it comes to cyclomatic complexity, and that's brutally hard to understand and maintain. The second most important metric is cognitive complexity. That's the ease at which a human brain can understand your code. When I began my career and I was writing code, I would try to be as clever as I possibly could. You have a question? No, just say, okay. I would try to write code as clever as I possibly could. And now, 30 years later, I'm writing code as dumb as I possibly can. One of my mentors along the path was a senior engineer at one of the top US companies, one of the Fortune 2s, right, at the time. I was working for him for a year, and he knew I was getting ready to move on. I move on fast. Sorry about that. But he's like, Dave, I'm leaving soon. He's like, I know, Jim. You've been good here. So I'm like, before you leave, I want you to stay another month. I'm like, yeah, my word. Because he taught me everything he knows, changed my whole career. Dave Reed, wherever you are, thank you. And he's like, Jim, you've known me for a couple years now. What do you think? Do you think I'm a sociopath or a psychopath? I'm like, Dave, I know you pretty well. I'm pretty sure you have bodies in your basement, and I'm pretty sure you're a psychopath and a sociopath. He's like, good, you know me well. So Jim, what do you think my ability is to find you after you leave? I'm like, Dave, you're clever, you'll find me. He's like, so let's get this right. You've written a lot of code for me. I'm gonna be maintaining your code. I'm a sociopath and a psychopath, and I'm gonna be able to find you. So what are you going to do to all of your code in the next month before you leave? I'm like, Mr. Reed, I'm going to make sure it's all well documented, well commented, and extremely maintainable, and point out areas of concern. He's like, good, you understand me. And this is a real conversation I had, and he's right. Code needs to be maintainable. And anyone who's trying on purpose to do clever, slick things, I think that means you're a bad engineer, straight up, because we're not writing code for our personal edification. We're writing code for the person next to you who has to maintain it when you're gone. And it took me a long time to learn that lesson. Anyways, and that's what cognitive complexity and cyclomatic complexity are all about, writing dumb code that's easy to maintain. There's also technical debt ratio and defect density. And the other thing I prompt is code duplication. Please minimize any code duplication. So we'll look at this in a real prompt in just a few minutes, right? So what else do we have here? Here's some case studies on AI code generation. Woohoo. Hey, how much time do I have, by the way? I've been long on the tooth today. Hey, NDC in the back. 10 minutes? 23. Oh, I'm great, doing great. So the problem statement here, again, GPT can write code from a raw prompt, no problem. But they lack inherent knowledge of secure coding. We need to use some kind of prompt engineering as part of our lifecycle to get this right. So when we're building React, we're now shifting to client-side React again. We're going to prompt it in just a few moments. I want to protect against XSS. I want to validate data. I want client data and functionality minimization. I can view source and read the code. I have to minimize access control type logic in that code. I want proper client-side authentication workflows. I want proper handling of weird edge cases like user-driven URLs. So this is my high-level goals when it comes to writing secure React applications. And I start with the raw prompt, generate a React form as a user login. I convert the raw prompt into human language, describing requirements like ensure the form's resistant to XSS, includes input validation, and so on. And I translate those human language requirements into something a machine can understand better. So let me actually review, that's enough here. Let me review my actual main production quality prompt with you. There we go. Oh. I usually don't show this stuff. I'm productizing this, but who cares? I'm going to show it to you anyways. I'll give you a copy if you want. So let's look at these rules. Actually, let me drop it down to be a bit more, and I'll explain these to you as well. Anyone here a React developer or does JavaScript programming on the client in general? So a lot of you do, good. The basic overview here In the world of web application development, React is the main framework of the day, the most popular one. This is JavaScript in a browser that's receiving JSON to render a user interface. People use React because it simplifies complicated tasks in user interface development and has a security model built around it that's okay, but not great compared to Angular. Angular was the framework of the day. It's much better from a security point of view, but early versions of Angular were painfully hard to maintain, and a lot of people dropped away from it permanently from that point on. React is better from a maintainability point of view. Everyone picked it up, Facebook maintains it, and I think it's the framework du jour. Most of my customers are either using it or migrating away from Angular or Svelte to it in some way. The other framework of the day is Vue. I love Vue. Vue is awesome because it has a progressive learning mechanism built in. So you can start using it day one and start using complex techniques once you've learned the basics. Vue and React share the JSX template rendering language, which is its automatic escaper. So let's go through these prompts. Let me explain to you why I've set these up. Number one, the first four are just our quality metrics that I'm going to use. Author with low cyclomatic complexity. Ensure that the authored code maintains a very low cyclomatic complexity. Please use a small number of lines of code per function and have a minimal number of logical translations through that path. Number two, author with low cognitive complexity. Please make sure the code is easy for a human brain to understand. Number three, author with low defect density. This is kind of like a punt, right? Because you really don't know the defect density until you measure it. This is just like a push. I don't even need it, but I do it. Ensure that the authored code maintains a low defect density. I should remove it. It's a little bit of a punt because I can't ask AI to be low defects. It's trying to do that already. Number four, author with low code duplication. That is critical, right? Make sure that the authored code has low code duplication just to give me a good code base and good code reuse. All right. Number five, ensure that all user inputs are sanitized before rendering. Use libraries like DOM Purify. This is a nice, easy punt because I used to do validation and other techniques. This is way easier for AI to understand. I'm just saying, take any variable you're going to use, just DOM Purify it, and that will remove any malicious JavaScript for safe user interface rendering. I thought this was a bad idea at first. One of my customers was like, why not? This library filters out JavaScript very reliably. It lets integers, natural language, addresses all get through fine. Why not skip validation and just purify everything? And so I've been experimenting with this, and it works extremely well, even though it's against my nature as a security engineer. So nice, simple instruction that AI can understand and roll with. Next, avoid direct DOM manipulation. When you're using React, you have two options. You can use the React framework to render data, or you can use a ref and manipulate the DOM in a browser directly. And you shouldn't be doing this. Using a ref to edit the DOM is a horrific security practice because you're avoiding all of React's automatic escaping and security controls. So I'm going to say, hey, please use React's virtual DOM instead of direct DOM manipulation to maintain security. Ask for what you want, right? Number seven, use dangerously set inner HTML sparingly. Dangerously set inner HTML is a function that will let me render data raw in React with no security. So if you're going to use dangerously set inner HTML, make sure the content is sanitized, again, with DOM Purify to prevent XSS. Never hard code secrets. Avoid hard coding API keys, tokens, or sensitive data. One of the big anti-patterns I see in React, someone's using a third-party API, and they're embedding an API key in React in some way. And they try tricks to hide it, but I can find it with ViewSource or tools. So please, no hard coding of secrets of any kind in code. Number 9, use secure storage. Do not store any sensitive data in local storage or session storage or anything similar. I'll add that right now, or anything similar. Or index IndexedDB or similar. There we go. There's a more accurate. I've been wanting to do that for a while. So where is a good place to store sensitive data in a browser-based application? Unfortunately, the answer is nowhere. In secure software, we have our template code, which has with no security exposure. Then we feed it JSON to render React. That JSON has all kinds of crazy sensitive data. And in theory, you shouldn't store it in the browser in any way. I deliver my JSON with all the cache headers disabling caching. JSON hits the browser, the UI is rendered, and the JSON is flushed from the cache, and I store nothing long term. This is a pretty standard practice for secure banking and similar type software. So please don't store sensitive data in any of these HTML5 storage mechanisms long term at all. Number 10, validate all props. Use prop types or TypeScript to enforce prop validation. You have in React 3 basic element arguments, right? We have a type, a prop, and the actual data. A prop is basically an attribute in HTML. And I'm going to add to this. Use prop types to enforce prop validation, and only render props, right? Only render props in safe HTML attributes. I'm going to leave it at that for now, and I'll come back to that another day. 11, escape dynamic content. Ensure any dynamic content passed through props is properly escaped to prevent injection attacks. I'm going to do this one more time. And only render props in safe HTML attributes. Okay, good. I'll leave it at that for now. Number 12, validate URLs. Again, research I look at shows that 1/3 of successful attacks against the client is with user-driven URLs that are basically JavaScript or data protocol URLs. So validate and sanitize URLs before rendering or redirecting. Ensure the protocol is HTTPS and from an allow list of legal domains, and validate in React. What I'm saying here is don't depend on the validators at the API. When the API feeds you a URL that you need to render, have React validate that that URL is legal before it renders it. This is a practice I'm stealing from Angular, and it's a good one. 13, use safe URL loading practices. Check that URLs being loaded are from trusted sources and apply content security policies. This is a standard to avoid JavaScript injection. 14, use HTTPS. Ensure all API calls are made over HTTPS to prevent man-in-the-middle attacks. Straight up, we all know that already. 15, no client-side access control. Ensure that access control is not handled in client-side React. It must be server-side only. I can view source in client-side React. There is no place for access control in a client-side React app from a security point of view. This is a big mistake. This is one requirement I want to augment and explain why to my engine in more detail. 16, audit third-party libraries. Regularly check and update third-party libraries to prevent security vulnerabilities. How about this? Only use third-party libraries that are under active development and have no known security vulnerabilities in the latest version. A little more detail there. There we go. That's the main point I'm trying to make here. Only use libraries that are under active development, have no known security vulnerabilities. I can even go further and set more criteria like the cyclomatic complexity and similar if I want to get crazy. Number 17, limit inline styles. Avoid using inline styles or ensure untrusted CSS values are escaped with CSS escape to prevent CSS injection. This is a native JavaScript function for a value you're adding into cascading style sheets, like a color or a width, to make sure you can't inject your own CSS into a block of other CSS. 18, use static React templates. Ensure React templates are static and not dynamically created to avoid, I'll even say it, to create it to avoid template injection. And those, folks, are my prompts for creating React code. I know I'm an American. I'm full of myself sometimes, like when I'm talking. And I still hope that even with my sensational behavior today here in good old Denmark, that this talk was of value to you in some way. If you have a question for me beyond today, I'm jim@manico.com. I'm happy to share my React prompt with you. Does anybody have any questions about anything at all that I talked about today? Any questions? Yes, sir.
I love the idea of getting AI to verify that the latest versions of things are secure. How do you deal with the fact that the knowledge that these AI LLMs have date up to a lot has changed in the software we're using since that time that the AIs aren't aware of it yet?
The AIs are doing web hits now. Like I can say, please use the latest version of a library and give it a URL to that code base, and it's good to go. What's that?
ChatGPT does, but Claude doesn't.
Claude doesn't. That's why I usually use GPT to do my initial boilerplate, including library use, and I'm only using Claude for rapid iteration. And I tell Claude, hey Claude, dude, don't touch my freaking code. Just fix this one thing. And then it'll just give me just that function it fixed and not touch the rest. GPT will do live hits and pick the newest library better. So I think a workflow using both engines is rocking. What I'm building right now for myself is I have GPT-4 is my project manager. Gemini is my QA, and my final QA round. Gemini is whacked, but it does some miraculous. It's like a Ferrari. It can go fast and turn, but you hit the wheel a little bit in the wrong direction, you're against a wall. So Gemini is a little weird, but it does crypto miraculously well with Tink, my main crypto library, and better than any other engine. So I have a different microservice for all these different use cases. And I have a project manager watching the whole flow, pushing it back and forth for different reasons. If I fail certain criteria, I go back, fix. So I think opening up to different engines is critical. Like Amazon's GPT, when I first looked at it, it's horrible at code creation. Then I'm like, give me some Lambda configuration scripts for this purpose. And I'm like, oh my God, it got it right. No one else got this right even close. So the more I study this, the more I'm building different services to pipeline code through all the engines for different reasons. And it's changed my world in a big way. Is that helpful or? Yes, sir. Threat modeling? Yeah, I'm not a big believer in threat modeling. What threat modeling is, you review code, you draw pictures on the wall of your code, you do like theoretical tabletop exercises attacking that code. Boring. Instead, I clearly specify secure reference architectures. And I can do threat modeling at the end if I have to, but threat modeling is again, there are good uses. If I'm going to build a brand new architecture, I do threat modeling. If I'm going to make a big architectural change, I do threat modeling. And that's mapping out a system diagram of your software and having a security expert analyze it. It has its place in the world. But if I'm building software from scratch with AI and I'm doing threat modeling in real time, I help write the AS. I'm not as good a coder anymore, but I'm a security engineer. I'm one of the authors of the ASVS standard and other standards in security, so I know security engineering real well. So I can put those into prompts like I just showed you, and I don't need to do as much threat modeling because what I'm building already has very strong security requirements. So I don't do threat modeling per se in this world. I focus on clear architectural reference architectures and security guidance that build secure software, similar to threat modeling. Is that fair? I use ChatGPT 4.0. I use Claude 3.5. I'm starting to use Copilot now that I'm allowed to do prompt engineering with it. And I use Gemini, and I think it's called Whisper. It's just recently, one of the Amazon engine, and I'm using those 5 engines in a pipeline right now. And again, threat modeling is a big deal right now. Everyone's talking about it. I just sat in so many threat modeling meetings where I spent 8 hours diagramming someone's software and talking about it with no value. I'm a little bit burnt out on it, but it does have its place in the world. With AI, I'm focusing more, again, on secure reference architectures and security requirements And I'll do threat modeling at the end before I go live with the team. But it's less of my focus in this talk. But a fair comment. Do you have a question, sir? Yeah, let me bring that one back, right? Let me go back to this. And you picked out the one mistake in here, and that's totally fair. No, that's good. I would just say this. Only use third-party libraries that are under active development, have no known security vulnerabilities in the latest version, and use a low number of dependencies. I prefer prime libraries without any dependencies. You're right. That's a workflow requirement. Now there's a code creation requirement. Is that better? Good. I'm really impressed. You picked out the one thing that made no sense here. Good eye. I applaud you for that. Anyone else? Good questions. Yes, sir.
Do you have like 5 to 10 browser windows open at the same time with different chatbots, or have you built some sort of tooling around it to combine all of them into one super chatbot?
I have one super chatbot. It's not even a chatbot. I'm just hitting. I have like my own interface, and I'm using their APIs. That's all. Very, very lightweight, and I'm experimenting with it. And I'm not building a product. I'm doing it for my own. For my own. Like I'm bidding on very large projects single-handedly. And they're like, what are you doing? I'm like, I'm using an AI pipeline. They're like, they're expecting a bid of like $4 million, and I'll bid a fraction of that. And they're like, we'll give you a run at this. And I finished a few of these and can make some good consulting dollars doing it on my own. So I'm using this to pump out big projects. And I make sure they have clear requirements for me, or there's no point in me doing it. So that's what I'm up to. It's fun. So it's a hobby. My company is a professor. Building enterprise systems with AI is my hobby. It's not even my main job. Yes, sir.
Is it reasonable to use the name of when like you reference another model, like from ChatGPT to Gemini? Is it reasonable to mention that has been created by another LLM system?
I don't understand the question. One more time, please.
I mean, when you go in forth and back through different LLM systems, is it reasonable to mention to the new LLM system that what has actually
Say, hey, Gemini, can you review this code? It came from your buddy GPT-4o, and I bet you could do a better job. What do you think? I think that's great. Back in an earlier version, I used to say, hey, and I'll give you a $1,000 tip if you do this fast. Oh, and it actually changed the results. So some very weird stuff changed the results. That's worth experimenting with. I keep all the sensational prompt engineering things that I do that make no sense, I politely keep out of this presentation. Like I give it a tip, I compliment it, and I do some weird stuff that in my study helps. I don't think that's going to last, though. We're going to see new generations of engines that have better models, better review of what they fed into it, and the shenanigans are going to be less important in the future, is my guess. But give it a try. Why not? AI is wonderful. Also this. Go ahead, chat. Here's a challenge. Open up GPT-4o right now and ask it to tell you the number of R's in the word strawberry, and it says it's 2, and we'll fight you on it. So there's problems here. So this cross-engine review is critical, in my opinion. Any other questions? My main hope is that this presentation, my sensationalism aside, was helpful to your world as a developer. If you have questions for me, or want a copy of this presentation or a copy of my prompt, I'm jim@manico.com. I will not market you if you email me. I really appreciate your time. Enjoy the conference. Go forth and write secure code. Thank you so much, everybody.